Anyway, hello everyone, I'm Craig Hitchman. I work for systems engineering with the automated test team. In the past, I've worked a lot with applications that interact with databases, and there's a lot of observations and kind of anti-patterns that happen when you build these applications. And I just wanted to make a presentation that talks about that and kind of gives some tips about how you might want to actually use SQL from the LabVIEW perspective. So, any questions before we get started? Awesome. All right, so we're going to talk about some background. We're going to go a quick crash course on some database terminology. I expect some of you have used databases before, and some of you probably haven't, so I'll try to do enough steps so that people that haven't seen it have an idea what we're talking about. We'll look at some SQL queries and what you might do in those. And then we'll look at an example of a database API and how we might use it in an application. All right, so background. I kind of already said this, but I've worked with some applications that use databases, and I find that it's easy to think that you can make LabVIEW do all this work, when in reality you want the database to be doing the work for you. So, in general, I'm not a database expert. I come from an engineering background, and I've kind of learned this stuff through like looking at blogs and reading about how you should do these things. And I don't have good recommendations for you should use this database engine or this database engine. However, regardless of what you're actually talking to, the way you do SQL and the way you actually make your queries tends to be pretty much the same. So what we talk about here can apply for pretty much any engine that you might be using in your applications. And there's a lot of different things I want to talk about, and we might not have time for everything, so despite that, please ask questions as we go, and let me know if anything is confusing. All right, so crash course on database terminology. A database, can I see this? Is a structured set of data held in a database. The schema is how those things are related together. It shows us the structure of our database. Where are our tables? How are those tables related? Tables are where our data is physically held. It's got rows and columns. It kind of looks like an Excel spreadsheet. The SQL is the language we use to actually interact with it. It can get data out of the database. It can put data into the database. And most of the time, this is how our actual interface to it. Any questions about this terminology? Who has seen this stuff before? Most people. Who has not seen this before? Okay. Cool. Awesome. Thank you for being brave. I appreciate it. There's lots of example databases. In your application, you probably have one already. For the purpose of actually showing some examples, I'll grab this one called Sakila. It's a MySQL database that is available there. It doesn't really matter. This is just one of them. Here's a part of the schema of this database. This shows us several tables and some of the relations between those tables. So specifically, what we're going to be looking at is the film table. Here. The film table contains a list of films, 1,000 made-up films. One of them is called Academy Dinosaur, for example. And those films have several properties. They have a name, they have a description, they have a release here, they have a language, all these different types of properties you might associate with what a film or a movie might be. We also have a list of actors over here. And they basically just have a name in this database, but presumably they have like a birthday and other properties about what type of actor they are and what they've worked on. And finally, we have a table called film actor. And this is the relation between the actors and the actual films they worked on. So, this is pulled from MySQL Workbench. You can look at schemas and see how things are related. And this is pretty common to say, okay, what are my tables and how do I actually think about them relative to each other? And this will help us create our queries later on. Questions about schemas? Again, quick overview, so not too deep. Often when you're actually making applications that interact with databases, you want a way to look at them and interact with them outside of LabVIEW. In my case, I use something called SQL a lot. It's a pretty simple tool. It's open source. It lets you connect to databases, look at the contents of the tables, look at how the tables are defined, and actually interact with them. So if your database is supported by SQL, you could use it. There's also lots of other tools that ship with databases by default that will let you look at what's in your database. But generally, it's really important to be able to see what's in there and interact with it to actually be able to make your queries efficiently. And this is separate from your application completely. So, if we opened up a table connected to our database with SQL, you might see this. Now, on the left, we have our database and the actor table. And within the actor table, we have a list of people. The first one being Penelope Guinness in this case. So all of a sudden we have a way to see what's in our database, what's in our table, what information is stored there. Now, it's a viewer, but it also lets you do queries. So in this case, we're doing a very simple query, very simple SQL statement we'll look at in a second, where we're selecting all of the data from our actor table. And down here you see another list of actors. In this case, it's the same list we saw from the table because we're just pulling everything from the table. And again, you see open up. Again, this is the first one on this list. So this viewer lets us see what's in the database and query data out of it. And indeed, this lets us build our queries outside of LabVIEW, outside of our applications, to make sure they work. And then once they're going, we can integrate them into our applications. So this makes our life a little easier to be able to do this separately. So typically what you do is, when you have an application, you have to first figure out, what do I actually need from my database? What am I doing with it? In this step, what data do I want? Once you have those definitions, you can build the queries to get that data in these external tools like HiSQL. And once you have the query working, performing like you want, you can bring it into your actual application. That's typically what you do with these things. SQL queries themselves are built from keywords. It's fairly readable. If you've never seen these before, you kind of can read through the text and make some sense of what they're doing. It's built on different keywords. Specifically, you often see ones with select, with from, and with where. I capitalize them for convenience. It makes it easier to see what's the keyword and what the other things in the query. So in this example, the from keyword says what table does the data come from. In this example, you can see all of these queries are pulling from the films table, which is the list of films we saw previously. The where, in the last query, is basically filtering within this set of data, what do I want to make sure is a certain value to kind of select out, to kind of trim my results. So in this case, the last query is only to return results where the title of the movie is Academy Dinosaur. And select is how you format that data. In this case, we have two different ways we're selecting. One is grabbing everything in the star, it's a wildcard. Just give me everything from the table. In the other case, it's grabbing specific columns out of the tables. So there's lots of other keywords. I'm not going to talk about them, but here you should be able to see, oh, I'm going to select the title and description from the film table where the title equals Academy Dinosaur. That SQL query will pull that data out of the database. Any questions? Cool. All right. When you're actually doing these queries, they're going to become more complex. And very commonly, you're going to be doing joins between tables. Joins is how you use the relational nature of these databases to pull multiple things together. This is an example of a call that is figuring out what actors worked on a given movie title. So where the title is Academy Dinosaur, we're going to get the actor first name concatenated with the actor last name. This is going to give us a list of actor names that worked on a given movie. Now, these joins is how we're relating these tables together. We're joining, first starting from the film table, we're saying film is related to the table film actor, and film actor is related to the table actor based on the ID keys. If you haven't seen this before, this is exactly how you do joins in databases, and you'll see this everywhere in the queries. So if you're not used to this, I recommend, you need to use it, I recommend practicing this and getting a good feeling for how to do joins. There's all different types of joins, I'm not going to talk about all that because there's lots of material there that's necessary. That's a query. All right, well, overall, I don't want people to be afraid of SQL. If you're going to be able to use databases efficiently, with any sort of large size application, you have to know and be comfortable playing with it. There's tons of online resources for this. Even just Googling how to get data out of a database will find you 5 different tutorials for how to do this. So I really encourage you to play with this if you need and get somewhat comfortable with it. SQL syntax is relatively universal. No matter if you have MySQL, MongoDB, that's a little bit different type of database, Microsoft SQL, SQLite, all of these different type databases and more tend to have a basic set of SQL commands that all are almost the same. There are some small features that will vary database to database, but they're usually the specialized features on the side. So all the queries we showed today will generally work in any database. Finally, if you build these queries in your external tools first, you'll save yourself a lot of time instead of trying to bring it to LabVIEW immediately. All right. There's lots of APIs to do this in LabVIEW. The primary one that most people have probably seen is the Database Connectivity Toolkit. Who's actually used that? Most of the room. Awesome. Have any of you used any of these other toolkits on the Tools Network? Oh, actually a fair few people. Depending what you need to talk to and depending on your database needs, I'd recommend finding the right API. This might be an API provided directly by the database vendor. It might be a toolkit. It might be a tools network thing. These are all awesome. I haven't used all of them myself, but generally this is going to be defined more by your application than what I can recommend here. So here's are some examples. There's more past this, and I recommend that you have some sort of API first. Now, given an API, there often are examples. And the pattern I see with a lot of examples is that they try to hide the SQL from you. They try to make it easy to get data out of your database. And this is a fairly noble attempt. People might be afraid of SQL. They might want to have an easy interface. This example is from the Database Connectivity Toolkit, and note how we're pulling data out independent of a given query. We're going by row, we're pulling out different columns of stuff, and we're getting data out. My experience is no one actually wants to use a database like this, and if you are, your application doesn't perform well because you're just pulling out tiny things at once instead of actually using SQL as a language. So what I challenge people to do is use SQL in a more raw manner to get the data you actually need rather than using these simplified APIs. So for simple queries, these type of abstractions might help you. It might make life easier. As things grow, they'll actually add additional challenges to actually using databases. At the end of the day, you're going to want to be using some sort of SQL for these different types of things. Has anyone seen this before? Has anyone had that challenge where they started with simple queries and then they didn't really push you to the next level in terms of performance? A few people, potentially. Well, if you try to build stuff off simple queries and simple queries alone, sometime down the line you're going to have a performance issue that can't be solved with just those simple queries. So let's look at this map. In this case, this middle block represents a query function. I find it very convenient to have a function that has this SQL query in and an output of data. This is kind of the simplest block I could show you in terms of how you do an SQL query in LabVIEW. So within this function, there's like 6 database connectivity toolkit APIs. That could be any API. That could be discussion with talking to any specific database. But the key is we have an SQL statement, an SQL query, and we have some array of results out that we format into our actual data structure. Yes? Because it's saying from film.
Which file?
This? I've statically defined it in that function to say connected to the database. You might have other inputs to this for what database you're talking to, what user you're using. I statically defined it for this API. That's not good practice, but for an example, it works pretty well. So let me run this VI. I just want to show you what it looks like. I don't think I already put it. Of course, it's on the wrong screen. So if we had this function, if this is our get all films. I have more VIs in here in the example. It's also, you should be able to download these, by the way, if you want to look at them after the fact. They're in the NIWeek app for this session. You should be able to download the PDF slides as well as the example code I have here. It should be available if it's not. I uploaded like an hour ago, so if it's not here today, it'll be here tomorrow. Anyway, here's the same VI we were just looking at. Again, it's pretty simple. We get our query, return our data, we format it into our type def, which is usable, and we get a result. So here's a list of all the movies, and this is the same list of films that we actually can see in IDSQL in the actual database. So, any questions about our first query? Yeah?
Are you using parameterized queries?
Not for this. Great question. I'll talk about that later. All right. Another function might be the one that we talked about earlier that gets the list of actors for a given film. In this case, we're doing some string formatting, which we'll talk about later in terms of making this better. But it's a little bit more complex than an SQL query. We're doing some joins, we're doing a where, filtering based on film title. But at the output, we have just a list of actors in the string array. So this is another simple type of query we might have. Cool? Questions? You okay? Awesome. All right. Based on these two functions, we can have a discussion about what commonly happens in these applications. We have two functions. We have a function that gets the list of films, and we have a function that gets the actors for the film. Now, if your client or whoever you're working with asks you, oh, I need a function to get the list of films and all the actors for those films in one return, how could you implement that if you didn't want to do any SQL based on these functions? What do you guys think? What could you do? Can you build that function from these two functions? Yeah? See a few nods? You might do this. You might say, I'm going to get all the films, I'm going to iterate over that film array, and I'm going to get all the actors for each of those films, and I'll bundle that together, and that'll be my results. Awesome. You just made a query that gets all the films and all the actors for that film. This is great, right? Who likes this? It would be very slow. Now, if we weren't talking databases, if we were talking hardware, this might be the way you have to do it. And this might be perfectly acceptable. However, when you're interacting with databases, when you start doing types of things like this, you should pause and think, wait a sec. I'm calling, in this case, 1,001 SQL calls to get one subset of data. Now, if that database is on your local machine, you might be able to do this quickly. And in fact, when I run this in my example, it does run quickly. But if the database was in a different state, and you have 60 milliseconds of ping to that, each of these calls will take 60 milliseconds at least. And if you add that up times 1,001, that is lots of time. And this is where you see bad performance. Is people thinking, oh, I have all these basic building blocks. I can just aggregate them together and get the data set that I want. But in reality, you should do this a different way. Any questions about this? If you take anything from this session, when you're interacting with databases and you see this happen, you should be afraid. And you should think, no, please, I need to do this differently. Okay?
Is there a generic recommended practice for once you retrieve the data of interest, once you house the data in, like I see you've got an array of clusters,
yep.
but if you say change, if you want title and something else, how the whole cluster changes, that's to propagate through the code.
Usually it's useful to get somewhat of a superset of data. I mean, you can make so many different VI calls that you have huge API, or you could try to make a more generic type of interface like this, where it gets a list of information, most of which is, well, you can pull out a list of title and description just from this type data. Now, you can look at that in terms of performance and say, well, if I only need just the title and the description a lot, maybe you make a separate query that just gets that information. So like this could be easily updated just to pull these first two fields and not the rest. But this also could be done where you just iterate over this after the fact and pull out those by themselves instead. So there's a big discussion of how many queries you end up building versus what your actual needs and how you format it. Answer your question?
Yeah, I'm just wondering if variant attributes can also be used with variant all of that.
You have a database, use the database, don't use variant attributes. That's what I would say. Again, like if you need to format it differently, you should make a different SQL call to format it the way you want. And that's an example of, oh, I can use variant attributes. I can use LabVIEW. Well, if you have a database, the database can probably also do all that stuff probably faster than you can because it's a database. So, yeah. All right. So, often what I see is that people that aren't comfortable with SQL making new functions from supersets of old functions. The benefits of this is you don't have to make the new SQL query. It feels nice. I'm just aggregating previous functions, but issues are performance, long-term maintainability, and stuff like that. So, any questions about this? I don't actually have an example of inserts in the presentation, but in general they follow the same exact pattern. We will talk about parameterized queries, which are usually the best thing for inserts. So, we'll get there. All right. Overall, SQL is really powerful. And designing these SQL queries to get exactly what you want in a single query should be your goal for any step of your application. This not having performed structured query language programming is from the description of the database connectivity toolkit. That is our marketing material for this toolkit. And this is exactly what I'm saying you shouldn't be trying to do for your actual applications. Typically this is okay if it's really, really small and simple, but in reality, if you're expanding this up, that is not sufficient for what you want. Your application should use complete SQL capabilities to offload work to your database. So if you have an application that does something like this, you can look to optimize it. You need to identify where are you making lots of unnecessary SQL calls and where you want to first optimize to make that and reduce it down to less table clicks.
So, in the example that you had where you concatenate that last numbers,
Yes.
like all that work is being done by the server.
Correct. Correct. That's an example of an iteration. So this is what you might arrive at after optimizing our initial query that used the for loop. Now, there are several steps in this iteration process. And I'll show you one of the ones before this for usefulness. So we have our function for get actors, get all films and actors. Well, the first run of this is the one that does the for loop iteration over the functions, right? This is the one we've identified as performing too slowly. The first thing we could do is we could rewrite this query to only be one. Now, depending how you do this can make your life easy or hard. So in this case, what I can actually do is show you what this looks like in SQL. So in SQL, which I mentioned, we have this improved query, presumably. We'll go back.
So NIWeek is just the front end of the client's SQL, right?
It's just a database query thing. It makes it look like Excel, makes you see how everything is organized. All right, so this is an example of putting a query in here and running it. You see this result is 8 by 5,465 rows. Now, the way the joins are done here is that for each film, every actor gets aggregated on the right. So if you scroll over here, you'll see that we have multiple listings for Academy Dinosaur. And for each of those, we have a different actor name that we've already concatenated. So we're already doing some work here to concatenate the actor's first name with the last name. But other than that, we're duplicating the film information multiple times for each actor that we want. So one thing you can do with these queries is look to see, well, how can I reduce the number of rows the query returns but still get all the data I want? So we've already moved to one query by doing these joins, but we're still having a lot more rows than potentially we might need. So the next step might be to say, do a group function. And I'm not going to go into this too much, I don't quite have time. But similar to that, we might use a group concat function here, which will actually concatenate the grouping of names into a list that's comma separated, which is a convenient thing. And our previous LabVIEW code had to do it manually. So the old function, had to do this fancy thing where it inserted into the array if it wasn't there, and if it was there, it would insert the list of actors so it would aggregate that list of things in the same way that our previous query had it. It's a little bit complex, right? If we make the database do that concatenation of names itself, it's easier. Which is what this function does. Here, note the actual parsing in this for loop is simple. We say, oh, I get my information, and my actors is already comma separated, and I can break that back into my array immediately. So, questions about this idea? Okay, I want to assume everyone's mostly okay with that.
When I'm looking at the present table, I first look at columns and then look at rows.
Sure.
Did you already look at columns and do this?
In this case, there's 1,000 independent movies, and the point of this query is going to list all the movies. So the minimum number of returns we can get here is 1,000. In terms of the columns, I mean, you could not select some of those things. So, sorry, does that answer your question?
Yes.
Cool. Okay. I'll move on. So, summary. These ideas are pointing to using a database to its abilities, using it to format data, using it to do the work for you. You want to avoid aggregating multiple queries together. You want to design them to get what you need them to call. And sometimes even a single query might be slow. You might want to iterate and update that SQL design to make that query faster as well. which is kind of what we saw where we had 4,000 rows returned. We can trim that down to 1,000 by concatenating some of those columns together. Cool. So earlier I showed you this query. Sorry, yeah? Question?
What is that last bullet on the previous slide about?
Identify slow queries and iterate on them. If you've made one SQL query that gets all the data that you want, but it takes 2 seconds to execute, that's probably still a problem. So there's things you can do to profile that query and see how can I make this more performant. What am I joining on between my tables? What's actually taking a long time? I have a slide in a bit that will show you a function to do that. Does that answer your question? Yeah. Don't pull up your query, yeah. So I showed you guys earlier this, and somebody hinted at parameterized queries, which is the answer to this, but let me ask you the question. Is this SQL query API function, is this safe? Is it safe to do it like this? What are the potential dangers that we run into when we do this?
SQL injection.
SQL injection. What is SQL injection?
Entering something else than just the title.
Okay, so maybe not just the film title is in that string. What specific character are we worried about in here? Single quote. Notice how the single quote denotes our film title field. So if there's a single quote in this film title string, our query all of a sudden is not the same query it started with. And this is a common thing you'll see in web applications. People say, oh, I got SQL injection attack, because they weren't sanitizing their inputs properly. Now, who has seen this type of thing? Who has done this? Yeah? I've done this. I did this for years before knowing a better way. So, at the end of the day, you have to determine how worried are you about injection attacks. For most of our applications, it probably is fine. If you're doing a web app, it might matter a lot more. But if you find yourself doing this, you should think, there's a better way. I don't have to do any of this. And the answer to that is parameterized queries. Parameterized queries break up the query string from the actual data passed with it. So you pass the string, you're not formatting data into it, and you pass parameters separately. Whenever you're worried about injection or any sort of sanitization, the better solution is to use these parameterized queries. Sanitization is pretty much a losing game. Even this sanitization procedure, I guarantee you can be escaped. If you look online, you can find incredible examples of people using these fuzzy algorithms, finding strings that find that little case that your sanitizer didn't find and still having an injection attack against you. So this is a losing game. And the proper way to do it is to use a parameterized query. Again, this makes it kind of as simple as it possibly can be. Our query is the same except for a question mark replacing where we had that quote %s. Now this question mark denotes a parameter. For each parameter, you can input an array of the actual data you want for that parameter. And because this is passed to the database by itself, and because this is passed to the database as a separate parameter, there's no way for the parameter to change that query. It's a safe way to insert and query from the database. Questions about parameterized queries? Okay. Who's wondering what that little sub-VI does? Anybody? Yeah? Okay, I'll show you. So for the simple case, it wraps several things. The first level is an FGV level, which is gross. But the actual query is this. So it's 7 or 8 database connectivity VIs that altogether let you do an SQL query. It's very common and useful to wrap these things into a function that gets you query and data out, because that's the easiest way to think about this. If you have to wrestle with a bunch of database connectivity guys for every single query, your life is going to be a little bit painful. But this applies to any API. Some APIs give you that query block by themselves very nicely. Some of them make it somewhat hard. In fact, this is my complaint with the Toolkit, is that to do something not actually that difficult, like a query, you have to do all this stuff to make it work. Now, the parameterized query is similar. In my case, I did this, and there's a different VI for parameters. So, And there are database connectivity examples for this, but again, the example is a little bit crappy. You can work it out from the example, but it's not straightforward. So. Okay, questions about parameterized queries? I mentioned before that maybe your one SQL query is running slow. Most languages have an explain keyword, and you can put in explain before your query. So literally this query here is the same exact query that we had before, but now there's an explain before it. And instead of returning the actual data that the query returns, this returns the MySQL engine's, in this case, knowledge of how it builds this query and executes it across the database engine. So you can see we have 3 different results, and in this case there's 3 different joins. You can look at the documentation for how to parse these things, but in this case it's nice because we see there's 3 simple joins on different tables, and all of them are indexes, refs, or equivalent reference. So it's a performant query. If you use explain on a query that's really heavy and lots of work, you might find things in here that are not index rows or different things you can identify, say, okay, that's why my query is slow. So this might be a way how you identify slow queries. And there's so many tips like this. Yeah, question?
What tool is that?
This is Heidi SQL.
Okay.
You might not be using this, you might be using other workbenches or things, but
Right.
yeah. I found this very useful in my database interactions. Generally, there's thousands of tips about databases, and we don't have time to cover everything. So I recommend, if you have a specific problem, work on it, iterate on it. But in general, these ideas are what you need to actually be effective with databases. We mentioned views at the very beginning a little bit. Views are a way to simplify some of the queries you have to make. So throughout this talk, we've been looking at getting a list of films and a list of actors and running those tables together. If you're doing that query thousands and thousands of times and you're sick of having all those joins in your code, you could implement something called a view. And this is, again, specific potentially to MySQL, but other databases have a similar idea. A view is a table that is aggregated from other tables. So the query we had previously is pretty much what we have that defines this table. So if you make a view, your database is doing the work to make a table of what you want, and now you just have to query just one object. There's no joins, you do everything immediately, and life is happy. So that's what a view is.
A view will basically would actually physically copy the data with the table, or?
The view technically is another table. However, that table is defined by aggregate data from other tables.
So I'm just thinking like if your existing tables are 100 gigs, is the new table 200 gigs?
If you have a 100 gig database, you should have a guy that does databases completely. And I'm not that guy. Potentially, you could use a view for that. I don't know. I think, technically it's a table because you can query it like a table, but it might not duplicate the data. It's actually, the view is physically a query that stores the data, I agree. But it's also sometimes cached, so that if you're querying that view a lot, it doesn't have to recompute that every single time. So
it's not just like internally, it's not just a pointer or something like that.
I don't know.
It's not persistent for sure.
At least updates. If the data in the view from the source tables changes, the view will update as well. And again, this is getting into database optimization, and that's a whole nother topic. People's whole job is databases, and if you have a database that big, you probably should have a guy that does that.
Well, if it's not persistent, then it probably isn't actually stored on the disk. It's probably
It might be memory cache or something like that. But usually views are a way to make this a little bit faster, and it does simplify your API. Your call from joining becomes just a call from selecting everything from the view. So, question?
If you're actually fast performance can review,
It might not be different performance. Well, because the view sometimes can be cached. That was my understanding. So say you did 2 queries. Maybe it's the same, but
say you made a view out of a query,
Yeah.
and then you ran the query side by side, and you run them 100 times, and you count how many microseconds it is
Yeah.
for each one, or something. You're going to be able to do a side-by-side comparison, which one runs longer, which one runs longer.
I would expect the view to be equal or better.
Yeah.
But, yeah, you'd have to try it. Typically views are a good practice for these types of things. generally you want your data deduplicated in relational and different tables in terms of database terminology, and it changes depending on if you have really, really huge data sets. You might want to denormalize stuff, but that's a whole other discussion. Typically, views are a convenient way to take your common queries and put them into a single table that you can query from. It might not be actually a table, but you can query from film_list as a table in your LabVIEW calls. And you don't have to do all the work that this is doing to join all those columns together. Awesome. This is what we showed you in terms of the database toolkit wrapper. Some APIs have this already. They just give you that input-output in SQL. Some don't. And that's it. Any questions? Yeah.
Any other difficulties or differences when you're trying to insert data into the SQL?
Okay, good question. I forgot to address that. Inserting data is often best used with a parameterized query. So I'll go back to that query here. Note how our parameter is just a question mark. Your query might be insert into table name where values, all the different stuff. You have like potentially a lot of values that you format into. If you use a parameterized query, you have n question marks in there. And you can format in that size array of parameters. Now, the nice thing about inserts in this case is that you don't have to re-download that query every time. You can paste in the parameters and update it, rerun the query. So I would recommend using parameterized queries for instance. Otherwise, you kind of format it into an SQL script and do all the formatting for the numbers and stuff like that. Question?
What options are there for reading and writing databases on real time?
On real time, you cannot use the database connectivity toolkit, right? Because it uses ODBC, ActiveX, and all that stuff. One of the toolkits I mentioned, the Sapphire one for MySQL, is a LabVIEW native implementation. It's built on an old community example that did it, but they fixed a bunch of bugs apparently. It seems to be pretty good. So, and there's also other things like you can get native MySQL databases running on Linux RT targets, for example, because they're cross-compiled for that sometimes. And yeah, you just have to look for an API that supports that interface. So there are several that exist. But I can't point you to any specific one other than the toolkit. Yes?
Two comments. The first is, we are talking LabVIEW, so that's graphical.
Yes.
And there are graphical SQL editors, so for those of you that are not comfortable with SQL itself, you can see the tables and you can draw lines and link the tables and decide whether you want a left join or right join or whatever. It's a lot easier to use than SQL if you don't know how. And then the other one is that if you don't know XML, you should learn XML because that allows you to create the data structures that let you read and write to the tables more efficiently.
Okay, and there are tools that do this in a graphical manner, as you're saying. I personally haven't used them much, so as long as they let you do the full features of the queries that you might need, they should be awesome.
Awesome.
There are some toolkits that I've seen, like the Query Builder API. I think SE, System Engineering, used to have some sort of database Query Builder package. I don't know if you guys have seen that. My experience with it is that for most of the time it's really nice because you can build your queries, but sometimes you need a specific type of query that it doesn't support. So those might be awesome, but sometimes they might be difficult. So I don't know. Yes?
Jump has one that I requested. Halfway that, can you get a name for those graphics?
The simplest one that I've ever worked with is Access. And you can use Access as a front end to quite a few SQL databases.
Microsoft Access?
Huh?
Microsoft
That's
Access?
Microsoft Access. And then from there, you can actually have it show you the SQL string, which you can then paste into.
That's kind of an example of using external tools to make your query and then moving it into your application.
Sure.
Yeah.
Whole other thing. So one of the things that I can do is I have a variable length ingest feeding into a log that's on SQL.
Okay.
So sometimes I get one line,
Yeah.
sometimes I get 9,000 lines. And when I'm doing writing and I'm trying to go as fast as I can with this, making 1,000 one-line inserts is slow, and it actually ended up being optimal to write about 1,000 lines at a time. If I go more than that, it slows down.
Probably specific to your API and your database too.
The performance-wise,
Yeah.
but there's got to be a way where you can say, hey, just stack these, and then when they reach a level, then do your insert. Is there a way to do
You
that?
can do things with transactions where you group up multiple queries together, and you only send it to the database in a chunk. Other than that, I mean, other people might have some ideas for you, but do you have a
Yeah,
reply?
depending on what kind of database you're doing, if it supports, gosh, I lost it. Oh, what's the name of the queries that reside on the database?
Oh, functions or procedures, yeah.
Functions and sort on the database. Thing to do would be to write the procedure there, and then you can pass the data into that procedure as a chunk and let the database do what you have to.
So the database has pre-existing knowledge of what you want to insert, and you can kind of call it, so it's got more preparation in terms of putting that in the database.
I have an application that when I first started working on it, we were writing, can't figure it out, 1,000 elements of data for anywhere from 1 to 6,000 products.
Wow.
And we were trying to, it was taking forever because they were updating each bit of data independently.
Like individual inserts for each thing?
Yeah.
Yeah.
So we created an array of the data and then created a sort of procedures that I was looking at.
And effectively, that's collapsing multiple queries into one.
Yeah, it's an array. It's a sort of procedure that does a batch update, also make use of the database engine more better, and I enhance the performance of that particular application by about 99%.
That's awesome. That's exactly the example I found too, is that if you're basically doing it, multiple SQL queries, you can replace it with one, either a procedure or even just a larger query, and your performance goes way, way up in terms of how long it takes to do that. So, question?
Any of the APIs you listed are really working with any APIs that are, say, cloud-based or something to actually build the queries? I mean, most of the any web apps and anything I've done like
They have like ORM, object relational model stuff, and they have like a class that represents the table and group. Is that what you're talking
Well,
about?
yeah, I mean, when you're adding all of the where conditions, yes, you're going to end up with a single where, but you may have a dozen different conditions of all sorts of deals. And historically, I've seen, you get an array of conditions, an array of.
Yeah.
I mean, whenever I've worked with any databases within, say, web applications, it's extremely rare that I've ever written actual SQL query.
For those-
You are going to say join table, join, and then the engine,
Builds the
API,
query.
whatever, later actually parses.
Yeah, it's much more common in web apps where you have those, I think they're called ORMs, where you have a class representation of your tables and you can kind of build these queries in that way.
It's not even related to the database itself. It's actually, it's the communication to it. So like your API, I mean, I guess my question is, have you seen any class-based APIs where you would actually build the queries and then eventually you just call a execute on that, so they have an array of conditions?
The closest thing I think is the SQL Query Builder. It's not class-based, but it lets you kind of pass strings between them and it aggregates and does all that work for you. There's functions for adding a filter clause. And actually, the cases where I've seen there being a large chunk of filter parameters based on like many different user options.
Yeah.
It had a big cluster type def coming in, and then it passed those into each filter, make a filter parameter VI, and then if it didn't have anything, it would add that, and it would kind of dynamically build your where clause based on those things.
Okay.
I don't know an example of a class-based one, but you probably can build one.
I was just curious, I mean, I don't know if you know the last quite a bit of that, and in that example, they never use SQL, they're always talking about it.
Yeah, I think it's more common in web apps, and honestly, it's a whole different world of stuff that I know a little bit about, but I'm not from there. Thanks. Question?
Still a little confused as to why the parameterized method is preferable over just concatenating the from task.
Awesome. I can explain it again. So this string chunk is sent to the database by itself. Okay? So no matter what is in the parameters, the database gets the same query. However, with the other method, if your question mark, your %s, your string, or formatting into that string has a single quote or something in it that's bad, you can actually change the query. You can think that as it's going through the string, oh, I've reached the end of the string chunk, but in reality, you're in the middle of your actual string data. And then some nefarious user could put a colon, drop all tables, you know, destroy a database type thing. That's the classic example of
Shouldn't
SQL
that
injection.
character still be included in the thumbnail string?
It won't, because the database is doing the work. The database knows the exact query, because the question mark, and the database knows to put the parameter in by itself. So the way it actually builds up the query in its engine is always the same, and it knows to put the data in that specific place. So, yeah.
Your other benefit is that you won't have to parse the SQL statement once.
Yes.
So whenever, if you do it with values embedded in, then it's got to parse that each time for each data point.
Right.
You're trying to insert. If you're doing it with parameters, then you won't have to parse that.
Right, the SQL ticket can be reserved and kept, and you can update the parameters and reapply that multiple times. Is that what you're saying? Yes, yeah, that's an awesome use of this. Any other questions? Yes.
If you design something where you have a lot of parallel functions that are accessing the same database,
Yep.
you can run into a deadlock situation where you're all trying to get the same table. And the database usually has a timeout before it turns out a deadlock error. If you have enough of those going and you're using an interface that you can worry back to back, or you're using .NET to call into the database API, those calls take the LabVIEW thread away. So
You can't abort it or something.
literally freeze your entire application and you can get deadlock shit.
The databases do have a thread limit usually. They can have a certain number of active connections, and if you're running things in parallel, you normally have multiple connections. From there, if you're doing queries that are locking tables, which isn't normal, most of the time you're just pulling it out of it, it doesn't lock the table. If you're doing like inserts that potentially can deadlock, it's almost more of a query thing at that point. I mean, you should be designing queries such that they don't potentially deadlock themselves.
Sometimes your database is designed by somebody else though,
Sure.
and they have deadlock problems inside the API somewhere.
Yeah.
The thing to note though is that you're taking all of the Windows threads away from LabVIEW, starving the threads, and the workaround is to move all your database to the PIs into a separate application. So that you don't starve your main application with threads.
Interesting. Great tip. You ever hear that? So, if you're running out of threads because it's spawning so many connections and deadlocking, you can throw it in a different execution system. This isn't going to be a properties type device, or?
Yeah, you take your APIs that are your APIs in the database, and instead of having them, use callers execution, put them on the DAC executions, so you're not using. And then that way, you can give them their own little thread, and they're not using that.
So, what are you specifically talking about? I've never seen this myself, so.
It sucks when you run into it and it takes a week to figure out what's going on.
If you open up VI properties for your VI, you can go to execution. And there's a execution system option here. And if you set this to one you're not using, you potentially can use those threads instead of the application threads and some of these pieces. Normally you don't touch this. Normally say this color is what you want. So I would recommend not messing with this unless you see that. But, because you can have other thread context switches, stuff happening and stuff like this. If you see that issue, try different threads. If you're using like an FGV, you're serializing all the database calls anyway. And usually there's enough performance for that, unless you're really
Not large systems.
not large systems.
No.
Okay. Fair enough.
Our databases are measured in terabytes, not
Yep.
gigabytes.
You are way above what I have had to deal with myself. There's a survey, by the way. If you want to take that. Tell me how terrible I am. I can stick around for questions if anyone wants to talk to me personally.